let's wrap up this lecture with a discussion of stability. We know that h of s is equal to p of s, our polynomial as determined by the right-hand side of our differential equation, divided by q of s. We know that the roots of q of s determine stability, so the poles of h of s, or the roots of the denominator of h of s determine stability. And just as previously, if the poles lie in the left half plane, left half of the complex plane, or in other words have a negative real part, then this system is a stable system. So for the example problem we were looking at, where h of s was equal to s plus 1 over s plus 2 squared, we've got a double pole. In this case at s equal to minus 2, so both poles lie on the negative real axis, which is in the left half plane, so this system is stable. Let's revisit a topic we haven't looked at in a while, and that's on inverse systems. Inverse system of a system with transfer function h of s has transfer function equal to the reciprocal of h of s. So note that hi of s times h of s is equal to 1. So the combined transfer function of the inverse system and our original system is 1. The corresponding inverse Laplace transform here of a 1 is just a delta t. That's our identity system has an impulse response of delta t, the identity system being the system in which the output is equal to the input. So in other words, we have h of s followed by hi of s with input in the Laplace domain x of s, and final output y of s. We can determine this intermediate output out of the first system, the zero state response, by multiplying h of s and x of s, and then we can find the total output by then taking that and multiplying by hi of s. But since their product is equal to 1, if hi of s is the identity or the inverse system of h of s, then the output will be equal to the input. So just as a trivial example, for the system we've been working with, which had transfer function s plus 1 over s plus 2 squared, the transfer function of the corresponding inverse system would just be s plus 2 squared over s plus 1. Notice if I wanted to find the corresponding impulse response of this inverse system, first thing I would do here is expand the numerator, s squared plus 4s plus 4 over s plus 1, and since the numerator is of higher order than the denominator, I would first do synthetic division before taking the inverse Laplace transform to find the impulse response of the inverse system.